So the goal of the story is to explain and compare, verify the solution which is in the IDEA StatiCa Detail. I'm meaning the bone stress or Anchorage check, and I will be also going continuously to show you hand calculation and prove that the results in the IDEA StatiCa connection, IDEA StatiCa Detail and IDEA StatiCa and my hand calculations are on the are same. So to prove that, I have created a wall. There is only one anchor with diameter 24 kilonewton, and the force that is used for um, like loading of the anchor is 50 kilonewton. You can see, and there is just wire fabrics which are capturing the tension in the concrete wall. Uh, yeah, so I will run the analysis, and what is very important, the anchorage shape at the end. If I come back to the transfer device like a anchor is straight. So right now we'll be talking about the straight anchorage type. So if I go back to the results and I will just extend the property grid on the right side. So here is the total force. I will scroll down and just like select only the anchor to represent the results itself. But at first, let me jump in back to the strength and the reinforcement stress. In the reinforcement stress, we get from the analysis 105 megapascals on the top of the anchor, and by the root of the anchor is 14.4 megapascals. So you can see on the left side, I have it the same. So I have only rewrite it to my MATCAD, and I would like to right now calculate the force that is inside the rebar. So I will jump into Anchorage, and from the Anchorage I will go to um, anchor to see that the force is 47.4 kilonewton. So you can see if I, let's say, multiply the normal stress in the anchor times the area, so I'm getting 47.4, exactly the same value, and by the root or at the end of the bars there is a 6.5 kilonewton, so it's perfectly matching with my calculation. So you can see this is the total force that you can get or you can receive from the calculation, and this is only like the integration of the stresses uh, over the area. So just, um, this is it. So my maximal force is 47.4 kilonewton. Right now, if you have like a pure anchor without some anchorage shape, so all the forces has to be transferred via the like design bond stress. Otherwise, the reinforcement will be pulling out from the concrete. So what is the F limb? F limb is very important. This is the limit force, and limit force. There are two conditions. For straight anchor, there is only one, and this is the bone strength, or sorry, the design bone stress. So my design bone stress should be based on the calculation of the IDEA StatiCa 114.4 kilonewton. So how to detect it? If I proceed on the left side to my hand calculation, so bone strength or bone stress is like area on the surface on the rebar, so P times D times L times FBD, and I'm getting 113.1 kilonewton. You can see there's only some roundings, so that's fitting really well. So if I check the utilization between the normal force, 47.4 divided by the um, limit force, so I'm getting approximately 41.4. So you can see this is on the left side also. So this is matching really well, and this is how the limit stress is, or limit force is calculated. Of course, we are touching also the ratio between the bone stress to design bone stress, which is visible here, and is 25.7 percent at this point. Um, or where we stop the calculation, or you can see, because right now we are, if you check it here, there is 102% of the utilization, so we should be over. So where is the issue, or is it correct or not? Yes, this is correct, because if we jump into IDEA StatiCa web page and write to search bar general description of ultimate limit state results in detail, we scroll down to part where is written Anchorage, and we need to check this diagram. So based on the diagram, I will just make a screenshot to interpret and show you how it works, because we are like checking bond stress or bond stress to design bond stress. So if we are here, so this is my like a design bond stress, and we are sometimes getting the utilization, let's say 105% of the uh, 100.5% of the utilization. And this is the reason, because we are not stopping the calculation on the like design stress, but on the slipping criteria. So this is the reason the FBD is a little bit higher, or the stress can be a little bit higher. So this is the reason why it's still matching and you will still getting satisfied results, but there is a little bit over. There's only a small portion of the exceeding of the percentage of the utilization. So this is perfectly fine, because we enable a really big slipping that is happening in this plastic region. So this is based on the experiment, so it's perfectly fine. So just for your information, how it works and what you can expect, and still satisfying results. Let's come back to the part where we consider some anchorage shape at the end. So I will come back to design, and here I will start with this perfect bond. So you can see there will appear some sign that it's a perfect bond, and right now tell me what does it mean. So if I come back here, I go to this IDEA StatiCa theoretical background. So based on the anchorage shape, we considered someone what is called beta factor, that is 1 for these two anchorage shapes, 0.3 for a hook loop, some welded bars, and 0 for straight bars. And let's say, if you check the values, or you can check the values in the theoretical background. So this is very important to know, because right now I will proceed to calculation again, but with different um, anchorage shape. So I will run it again, and what I will receive. So what I will receive, you can see it on the left side by the hand calculation. From the point of view of the check and the stress in the rebars, I'm getting 105 megapascals, but at the end there is 42 megapascals, not 14.4 like in the previous example, because there is some anchorage shape. So let's say more force is like absorbed there. Um, Based on that, I will calculate the normal forces. So the normal force is 47.5 kilonewton and 19.3 by the root of the anchor. But there is also another spring, so another force, 17.4 kilonewton, because this is the force that is taken over from the part of the anchorage shape. So this is the difference. This is difference that what is there. So right now I need to like make a check. So come back to Anchorage and show you the results. So I would like to see the same results, also the same force as in the detail, so as in my hand calculation. So you can see it. The left side is like fitting with my right part. But how the limit force is calculated? So this is like more complex, because there is a condition between two limits. The first one, the first one is or generally the condition flim is uh, calculate like a minimum of the summation of the bond plus the force at the end of the rebars, like the force in the anchorage shape. So right now I consider that it's perfectly bonded, so beta is 1. So my area of the rebars is 452, because this is diameter 24, and FUD is a design tensile strength of the rebar. So my forces that can be transferred via the anchorage shape is the same as the ultimate strength of the anchor 4, for the tearing out. So this is, if you sum it up, the bond strength plus the anchorage shape at the end. So you're getting higher value than ultimate strength. So it's 212 kilonewton. So my limit force is 212, and you can see it's perfectly matching with IDEA StatiCa Detail. From the point of view of the utilization, you can see I'm getting results 22.3% if I compare F total divided by the limit force. So yeah, this is the utilization also here, and you can see 22.3%. But what will happen if I come back and I will select this, let's say standard band as the anchorage shape. So I need to, in my hand calculation, make some changes. Like I will put here 0.3, and what will happen if I change it to 0.3? My force at the spring is starting to be different, and it's only 63 kilonewton. So if I sum it up, or if I sum it with two values, or these two values together, I'm getting 176. It's lower than 212, so this is the reason why I'm selecting the lower one. If I come back to IDEA StatiCa and calculate it again, I will get in my limit strength, or a flame is 178. So we can see small, maybe some roundings, but this is the value which is my limit force. So this is the explanation for every anchorage type. I hope you enjoyed the video.